Well, turbomachinery, or more generally speaking, rotating machinery, plays a really important role across many industries. So that includes generation of most of the world's electricity. It enables the extraction, processing, and transport of oil and gas, enables one to power aircraft, enhances the performance of automotive and truck engines through turbocharging, and many other applications. So these days we've heard a lot about climate change, and it's clear that innovative improvements to these machines can play a significant role in reducing their environmental impact. In addition, there are also some areas where government legislation now plays a role. And of course, improving efficiency also makes good economic sense to both the manufacturers and the end users of these machines. Well, rotating machinery has been developed and improved for many years now. So in general, the machines are already pretty good, and incremental improvements are getting much harder to achieve. So the industry has to take a very hard look at how to reach these goals and nail down the goals and commit to developing the necessary technologies and solutions. Just continuing on with what they have been doing will not get them to where they need to be in terms of their goals. So significant innovation is required to do this. Engineering teams are really challenged these days. Often the requirements set out for them push them into a design space where they lack experience. For instance, they may lack test data that can be relied on in areas where they must design. And some areas they might have to choose to use new materials, and others they would need to adopt drastically different design configurations. So in most cases they're dealing with a level of unknowns well beyond what they've experienced in the past. And with these unknowns comes increased risk. Leaders must look for new ways to get the solutions that they need, but at the same time they need to mitigate risks. So increasingly their organizations are adopting simulation or expanding the role that simulation plays in the product development process. So that's not to diminish the importance of testing programs. These are absolutely important, but rather simulation plays an effective role in concert with testing to enable them to get to the solutions faster and with acceptable risk. Also, with the expansion of computing resources and the increase in breadth and depth of simulation software capabilities, engineers can more effectively simulate the performance of their designs over a wider range of operating conditions than ever before. They can also do it earlier in the design cycle where it can have great impact. And in addition, the simulations enable more representative simulation of real-world conditions in that they capture the real physics that are there to a much greater degree of fidelity. By the time a prototype is created or a test is conducted, the design has already been thoroughly examined digitally, and this really speeds the development process. The real complicating factor is that while energy efficiency is critically important, it's not the only consideration. Other attributes such as reliability, durability, cost, increased operating range, and time to market are very important. So for instance, in the aircraft industry, it demands lower travel costs and less environmental impact. But they won't compromise on safety. If anything, the demand for safety is greater. Additionally, companies want increased on-time or on-wing time between overhauls, and that's important to reducing their maintenance costs. So most of these challenges find their way down to the aircraft engine suppliers, and the challenge for them is that conventional solutions to some of these specific problems are often diametrically opposed to one another. So coming up with solutions that balance all these considerations, that's where the real innovation is required. The common challenge is actually what I mentioned already. To improve machine or fuel efficiency, but also at the same time to improve these other factors that are important, like durability or operating range. So, for example, for an aircraft engine or a land-based gas turbine, the obvious way to improve the thermal efficiency is to increase the firing temperature. But in doing so, one runs into durability problems, since the temperature of the hot gases exiting the combustor may actually exceed the melting temperature of the high-pressure turbine blades. So designers are challenged to adopt more heat-resistant materials as well as innovative cooling strategies. Now, these new exotic materials that they may choose can be expensive and difficult to manufacture. So if one could use less blades in the turbine, then the costs could be contained. But that would increase aerodynamic loading, which then shifts a greater engineering challenge to the turbine aerodynamicist. And on the cooling front, liberal use of cooling air will keep the blades cool, but there's energy that is required to deliver the necessary high pressure cooling air, which serves to diminish the overall efficiency. So you can see that significant innovation all around is required to develop the solutions that address the factors that I mentioned. Yeah, you know, each machine faces its own challenges, again, due to large-scale market pressures. You know, it's true for pumps and hydraulic or water turbines as well. You know, for instance, a few years ago, the EU introduced legislation setting efficiency requirements for water pumps. And in early 2016 in the United States, the EPA enacted similar legislation. So these days, pump manufacturers must meet these targets or become quite uncompetitive. But for pumps, durability is still an important requirement. Industrial pumps are expected to run trouble-free for many, many years. And other factors such as flexibility in operating range, the suction performance, meaning the avoidance of cavitation, all these things remain important. Simulation can play an important role in enabling manufacturers to meet all of these requirements. You know, I won't go into all the details here, but there's a very informative article written by a leading pump manufacturer, Grundfos, and it's available on the ANSYS website in an ANSYS Advantage article called Pumped. So that's pumps. Now, concerning water turbines or hydraulic turbines, you know, efficiency has always been an important capability or important goal for them for many years. But with more renewables on the grid, such as solar or wind power, even hydraulic turbines are required to cycle more frequently. And they have to adapt to a wide range of operating conditions. They didn't face that situation in the past. And this is another area where simulation is a great enabler of innovation in design, as well as enabling them to troubleshoot existing machines that are now run in a mode that they weren't designed for. So again, we have a nice article on the ANSYS website by Andritz Hydro, and it appears in an ANSYS Advantage article called Force of Nature.